Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudewa Sos Ukobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 6, still on Newton's law of gravitation. It says a satellite of mass 1000 kg is orbiting the Earth at a distance of 1200 kilometers from the Earth's surface. Then 6.1 says, how does the force which the Earth exerts on the satellite compare with the force that the satellite exerts on the Earth? Then it says answer only greater than, less than, or equal to. Now we know according to Newton's third law, the force that the Earth exerts on the satellite will be the same magnitude of force that the satellite exerts on the planet Earth, just that it will be in the opposite direction. So our answer here is supposed to be equal to, and then now they're saying state the relevant physics law that you apply to answer the question. So we know that's Newton's third law, which states that when object A exerts a force on object B, object B will simultaneously exert a force of the equal magnitude, but in the opposite direction on object A. Then 6.2 says state Newton's law of universal gravitation in weights. Again, another definition. It says Newton's universal gravitation in weights states that every body in the universe attracts every other body with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Right. Then let's now look at a calculation question. Say 6.3 says calculate the force that the Earth exerts on the satellite to keep it in orbit, right? To keep it in orbit. Now, if you can look at this diagram, we can see that we are given from the center of the satellite, but then all the way to the surface of the Earth, right? So if we are to calculate the force that the Earth exerts on the satellite to keep it in orbit, that means the distance that we will require is the distance all the way from the center of the Earth to the center of the satellite, right? So we need the distance here in between this, the surface of the Earth and the center of the Earth is what we call the radius of the Earth, right? Which is always given to be a constant. The radius of the Earth is always 6.38 times 10 to the exponent of 6 meters. So that means which formula are we going to apply here? We are going to apply the formula F is equals to G M1 M2, but then we're going to make an edit to our R here. This is going to be R, which is the distance in between here, plus the radius of the Earth, right? So you get that. So it's R plus RE and then square. Sometimes they write this formula. You can say, or F is equals to G M1 M2 over D squared, right? So that means the distance all the way from the center of the Earth to the center of the satellite, which if it breaks down, the D breaks down to the radius, which is the distance here between the satellite, the center of the satellite to the surface of the Earth, plus the radius of the Earth. So note this formula there. Now our G constant is 6.67 times 10 to the exponent of negative 11. The mass of the satellite, we are given that it is 1000, but the mass of the Earth is a constant, and then it is always. So if you check the back of your formula sheet, the data sheet, you have mass of the Earth is 5.98 times 10 to the exponent of 24 kg. So it is a constant, it is always given, unless stated otherwise. Then 5.98 times 10 to the exponent of 24 over the distance in between. So we can see here it is given in meters, correct? So that means they converted this 1,000 kilometers into meters. It gives you 1.2 times 10 to the exponent of 6 meters. So we want to substitute the 1.2 times 10 to the exponent of 6 and then add it to the radius of the earth, which is 6.38 times 10 to the exponent of 6, and then we square that. Now it's time for you to just punch all this into your calculator. Then the force that will exist between the two objects will be 6,942.06 newtons, right? So this is the force of attraction, or the gravitational force between the satellite and the earth, right? Which will keep our satellite in orbit. So, okay, how are they going to mark this one? It's a mark here. Okay, it's a mark for this one, the formula. It's a mark for having to substitute in here, and then we have correctly substituted your mass there. And then also to discover that you needed to substitute that radius there, and then also add it to the radius of the earth, then the final answer. So that's supposed to be 5 marks in total. Okay, now let's look at 6.4. So this was 6.3. This was 6.3. Now let's look at 6.4. It says the mass and radius of planet A are 7.35 times 10 to the exponent of 22 kg and 1,737 kilometers respectively. Now calculate the acceleration due to gravity on planet A, right? So which formula should we use here? To calculate the acceleration due to gravity, we know the formula that is applicable is this one. G is equals to gm over r squared. Then let's go ahead, we substitute our constant, which is 6.67 times 10 to the exponent of negative 11. We are given the mass of this planet here is 7.35 times 10 to the exponent of 22. And then we are given the radius, but then our radius is given in kilometers. Therefore, we need to convert to meters. Kilometers to meters, how do we convert? We multiply by 10 to the exponent of 3, which is 1,000. Then 1737 times 1,000, 10 to the exponent of 3. That's it. So you can either just write it like this, or if you choose to write it in terms of decimals, using your scientific notation, this will still be 1.737 times 10 to the exponent of 6. So 1.737 times 10 to the exponent of 6 is the same as 1,737 times 10 to the exponent of 3. So do not be confused. And then that's 137 times 10 to the exponent of 3. But then remember, this should be squared. Now at this point, you just want to punch all this into your calculator, and then you have your gravitational acceleration as 1.62 meter per second square, right? And then how do they mark that one? So they mark the formula, they mark your substitution here, and then they mark the fact that you substituted your distance here and then you have converted, and then they mark the final answer. So this is supposed to be 4 marks. And then all in all, this was a total of 13 marks. It was a very good question there. So, okay, that's it for our lesson. Please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.